So 4.4, page 219, example 1. This is all it says. This is an easy one. They're gonna get your feet a little wet before they try to hold you underwater. Okay, so here's what it says. Find two numbers whose sum is 20 and whose product is as large as possible. What do you want to call the two numbers? That's the first thing.
L and M.
L and M. Okay. So L plus M equals 20. That's the first statement as an equation. And whose product is as large as possible. How would we write that? L times M is, and I'm just going to write what we're after so that I can get it. We want it to be as big as possible. I'm going to write max there. Does that make sense?
Yeah.
Now you could experiment with numbers and you could convince yourself rather quickly that the answer is 10. 10 for each. 10 for L, 10 for M. That product is 100 and it doesn't get any bigger than that. But let's say that you didn't come up with that or you didn't want to investigate by trial and error or by using some reasoning. This is the kind of modeling you're going to do. You're going to usually have 1 or 2 or 3 equations that come from the words and you're going to use them in conjunction with each other. Here's how I'm going to handle this. I'm going to solve this one up here for either L or M. I'm going to say L is equal to 20 minus M. Then we're going to replace that. Substitution's a big thing here. We're going to replace it right there. And I'm going to write 20 minus M times M, and I want to maximize that. Now I got something to work with. Graph that using X to M. Anyway, graph that with this, the variable, and find the maximum. It's not hard. But putting together the model sometimes can be. The thing that you want to graph can sometimes be very difficult to come up with.
I like it.
So when you graph it in a standard screen, you don't get much, but you can kind of tell, and from your experience with these curves, you can tell that thing's a parabola, and it's a parabola that opens down because its leading term is going to be negative. So that's one leg of a parabola is leaning right. So you know the maximum's up here somewhere, right? Do you know what I'm saying? So I'm going to eliminate some of my negative x's and expand my positive x's out a bit. And I'm going to take my y's quite a bit higher, like 150, because it's climbing up pretty quick. Oh, there we found it, see? Now we can see the top of that parabola. Also, if you're really good at math, and you're supposed to be, you understand that this thing's a parabola which opens downward, and so its maximum will be at its vertex. Remember how to find the vertex of a parabola without a calculator? In standard form, which would be this. Oh, 20m minus m squared. That'd be negative m squared plus 20m if you want it in proper form. Negative b over 2a. It occurs at 10, and its value is 100.
Oh my gosh.
Yep.
Cool.
Did not do one bit of calculus. If what forced you, and I'm not going to, but if I were to force you to do the calculus, what you would do is derive this function and find where the derivative is 0, because that would be a max or a min. And you know it would be a max because you know things about upturned parabolas. So we could do the calculus, but it's unnecessary because you have algebra skills that do it. And that's fine with me. Whatever skills work for you are fine. It's fine. It's coming up with this that is more important than anything else in this section. It's coming up with something to graph, maximize, derive, whatever. Find a vertex for. Coming up with that. That takes creative thought. That's where it's going to be difficult. Very next one is a great example of that. Don't look at the solution to example 2. Don't turn the page. This is our task in example 2, and they've got a picture up there. I don't care that you see the picture. That's fine. Don't look at the solution. It says a rectangle is to be inscribed. That means put inside. A rectangle is to be inscribed under one arc of the sine curve. Question is, what's the largest area that the rectangle can have, and what are the dimensions of it? Do you see that's kind of a tall order? Kind of an interesting question. So, we put together a picture like they have there. I'm gonna put it together up here so I can point to it. So one arc of the sine curve. It wouldn't matter which arc we use, but I think it would be the happiest arc would start at the origin and be positive. Okay. So it's gonna go, if this is a 1 up here, it's gonna go up like this, come back down the first arc, and it lands right here. What is this? We have to locate some things here. This was 0, this is pi, yeah?
Yeah.
Okay, and pretend that that is, really looks like the actual curve, and it's hand drawn, just the best I could do. And we're going to put a rectangle inside that. When it says inscribed, it means its corners have to touch the actual graph. So we're going to put a rectangle in here like this. And our task is to find out what's the area of the largest rectangle. You understand there are several million that we could draw, right? We want to find the rectangle with the largest area and find the dimensions of that rectangle. That's all you get. But it's enough. If you're clever, that's where you gotta open up the clever box and find it. Any thoughts?
Give me a second. I gotta think.
I'll tell you a really, really easy thought. What are you trying to maximize here?
Area.
And what is area for this kind of figure? That's where we're gonna start. But we can't maximize it now because we have 3 variables, actually. We have 3. The trick is going to be able to write L and W in terms of a single variable. This is L. I'm just going to put it up here so we remember this is L, this is U. What?
To find our length and our width. Our width is just the height of whatever point we're at. So we can figure out how to write what point we're at in terms of X and Y.
Good start. That's excellent. What point are we at?
X1.
X1.
How about?
That's sine X.
X sin X.
No, just hang on.
Just be like a 0.
Where is this? Is what I'm saying. Where is this?
0 plus X. So X.
Just X.
X.
Where is this?
X plus H. That sounds like a derivative.
No. X plus H. H would be something very
Pi
tiny.
minus
That's
X.
not-
Pi minus X.
Pi minus,
X.
is it?
No. Pi minus X. It's pi minus X. Or X plus L.
I think it is pi minus X.
I agree. I'm just trying to convince people.
Okay.
How far is it from here to here?
X.
X. How far is it from here to here?
So
How far is it from here to here?
Pi.
Then how far is it from here to here?
Pi minus X.
That's its location. Does that make it?
Wait,
Okay, I'm waiting.
so how come it's just 1x when there's 2x on it, or 1x on
The
each?
symmetry of this tells us that if whatever length this is the same as this. And what I want to know is how far out do I have to go to arrive at that point, right there? And how far out do I have to go?
Another way.
I would have to go,
Jacob, we don't need you. No,
I don't know.
Jacob, please.
Does anyone not get it?
No, no one does not get it. You
We all
sit down.
get it.
Kind of, okay.
Sam doesn't want you to be smarter than him. Sit
This
down.
plus
Oh my
X.
God.
So if you're trying to figure out how far out you are,
She understands now.
you're X far out.
Okay. Do you I can just not. Whatever. I'll just not.
Jacob, she doesn't.
those are both X's, so you have to go out to pi and back X, and that's a subtraction.
Oh, okay, I see
So I go up to say it, and then you get it. She says it.
Thank you, Mariah. Thank you for validating my teacherness. Okay, anyway, so my question is,
In this classroom.
That's
is,
garbage.
what is L?
Pi minus 2x.
Pi minus 2X.
Would you all buy that?
Yes.
Did we do this in pre-calc with all those fence problems? Is this what we were doing?
It's just totally different.
fence
Kind
It's different though.
This feels different.
So the length,
Yeah, we're doing it.
so the length can be replaced with pi minus 2x. Do you all understand the geometry of what we did there? Using the symmetry of this arc coming in, same direction. Okay. So now we need a height, but the height has to be in terms of the same variable or we can't graph it.
So it's just sine X.
Is it?
The height is,
That's the hardest part for most people to get. Sam got it right off. Do you
Yeah.
understand why it must be sine x?
yeah, because the height is
Any-
whatever the.
Any point on this
Just sign it.
is
Which is
out
sine
x and up the sine of that. So
Yes.
this point right here is x sine x. Do you understand that?
Yes.
Yeah, all you have to do is.
So
think
in-
So
about
the height,
x,
that
f of
distance
x.
right there is sine
Yeah,
x.
in other terms of thinking, that point is x, f of x, like Jacob.
We
said.
get it, Jose. Oh, jeez, Jose. We get it. We
For
all
myself.
know.
Jacob,
Okay.
calm down.
All right, so here's the deal.
At least I gave you credit.
That's the difficult part of this problem. Once you have a model that you convince is correct,
Halfway
a
done.
model in a single variable, written in terms of a single variable, you can maximize that, because it's the area we wish to maximize, we want to get the biggest one possible, so graph that function,
Okay.
Drink, have a Snickers.
try to find a window that you can tell things in, I mean, you know, whatever you can do. Minus
Oh wait, this guy should be big.
sine x.
Big.
It won't be very big.
I'm gonna do the exact same window I had. That's
What
oh, what the heck?
It's a,
The whole thing's a sign.
it gets bigger as it goes out.
Yeah, it looks like this, right? Because there's something, I'm kind of glad this happened, because there's something I
Oscillating.
failed to tell you about these modeling problems.
Can't go negative over.
Depends on the problem. The problem isn't this one. But listen, shh. What is the biggest? Think about the problem in the geometry. What is the very, very biggest value of x? That makes sense.
Pi.
Oh, yeah.
Pi minus x. 1.
The biggest value of x?
The biggest value of x.
Pi half.
Oh.
Sorry.
Is you can't come in pi and then go back pi. You can only come in pi halves.
Wait, what?
Would you say this is like the box cutting problem? It's like where
Yes,
you
it
cut
is.
the
Yes.
It is. So if I were to draw, what I'm saying is, can you see that x would be bigger if I drew this one? You see that x would be a bigger number if I drew that rectangle? But still, I can only come in
Yep.
halfway to draw a box. I can only come in halfway because I gotta come in both directions.
Could you go halfway? Could you say x
No, it would
is
just be a
pi
single
half?
line, your area would be 0. That wouldn't be the one we're looking for, but you could come that far. And that's the very absolute maximum. X that you can have is pi halves. Do you agree or not?
Yes.
Then set your window to go from x equals 0 to pi halves. That way you're not looking at any part of the graph that makes no sense to be confused by.
X scale pi.
Make your y like 0 to.
Okay?
For my x scale.
And then for your y. That's cool, that is. Or if fits the arc too. I remember this time.
It's not quite symmetrical. This is not a symmetrical arc.
It's not symmetrical.
Was this supposed to just be like that little?
It's like it's a tiny bit behind pi half.
That's what I get. When you let your y's only go to about 2 or 1.5.
Oh, I did 10.
Yeah, the numbers are very.
So it's just like that if I did 10. Okay.
Go find that maximum.
You just have a very disappointing curve.
Yes, I know.
You don't need to- you don't know. Keep beat that close.
Maximum is at 0.710, right? 0.71, we'll go with 0.71. So, no, the area, the maximum area equals 0.71. That answers one of,
Listen, I'm awake.
I'm gonna write a few more decimals.
Oh, what
0,
dimensions
4,
give
6, 3,
that
8.
area? That sucks. It's always, actually, that might not suck. I think we just.
Whoa.
That's our maximum area. Do you agree? That's the y value of this maximum?
Why is there 5 different decimals? I have 4654.
Oh, that was the x value. I'm blank. That's the x value. This right here is 0.7104638. This is not this.
So-
This is the A, which is 1.1222.
There, I'm just,
It's the y value, that's the area. My mistake.
Yeah, we just have to plug this in.
You following that?
Yeah.
But it's important also with the x because we still have to answer the dimensions problem. How long is this thing?
That is pi minus 2 times 0.7.
Pi minus 2 times this. Now let me tell you something about your calculator lest you have forgotten. List. The x value in your window right now after finding that maximum, that x value will remain in the x box until you change it. So
Which
if
is
you want to go
obnoxious.
calculate something on your home screen, you can type in pi minus 2x, and actually put an x there, and it will remember the most recent x value, which is this. 0.771.
2x minus 2 times 0.7.
0.771. 2x minus 2 times this. 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 enter, and you get 1.72.
That is whack.
Oh my gosh, that actually does work.
What is the width then?
The width is x sine x.
It's just
Sine x.
the sine of x, and that x is still the same x we are still in that mailbox.
What is 1.7 the X value of?
No.
0.65
or 0.7.
to
1.76.
We don't have a one.
We knew this.
Oh, that's the length.
Where are we getting the 1 point? How did we-
because the length was pi minus 2x, where x was this.
It just happens to also be 0.7.
The length of the rectangle is pi minus 2x.
Right.
And this was x for the maximum area. That's how far we came in when we drew our.
Okay.
So pi minus twice this is 1.7206.
At least these are like more sad.